Hi, welcome to this video. If you are new to this channel, I do encourage you to subscribe, and for those who are not first timers here, thank you for coming back. Today we'll be looking at the Shem-Prasad LeetCode series, and currently we'll be working on the average of levels in binary tree algorithm. So let's get to it. Last time out, I did a video on trees. I tried to explain how the tree data structure looks like, and I explained the depth first search and breadth first search. Please, if you did not watch that video, I strongly advise us to go and watch that video, because we'll be building up on that to work on these three algorithms that are in the upcoming questions. So today we are looking at the average levels in binary tree. So average levels in binary tree. We're given the root of a binary tree. We are to return the average value of the nodes on each level in form of an array. Answers within 10 raised power minus 5 of the actual answer will be accepted. So that is the margin of error. That will be, it's fine. So for example, we are given these three. On this level, we have just 3. So the average is 3. On this level, we have 29. That is 29 plus, that's 20 plus 9. That's 29 divided by 2. That's 14.5. And then on this level, we have 15 and 7. That's 20 divided by 2 is 11. So the average is 3, 14.5, and 11, which is fine. On this level 2, we have, basically, I think it's the same thing, because this is 3, this is 29, this is, so basically, that's what we have. The number of nodes in the tree is in the range of 1 to 10 raised power 4, and the value can be between these ranges. Okay, so let's go to the board and let's see how we can do this. So here we have our board again, and we'll be trying to replicate that. So we have, I think it was 3, we had 9, we had 20, and then I think we had 15, and we had 7. So basically this is what we had, and what we want to track is each level. So this is level 1 level, this is another level, and this is the final level we have here. So these are the 3 levels we have, and the average for this level is 3. The average for this level is 29 divided by 2, and the average for this level is 22 divided by 2. That's 11. This is 14.5. So basically this is what we have here, and we are trying to now write an algorithm for this. Now, based off on last video, you will know that for this kind of algorithm, I think the breadth first search will be best, because the breadth first search goes breadth-wise. It will go for every breadth. It goes breadth-wise on every level. So for the first level, it goes through the breadth. Second level, it goes through the breadth. And the third level, it also goes through the breadth. So I think that is the approach we will use. We use the breadth first search. But the problem now is, how do we keep track of what level we are? So I think the approach I will use, you could either create a class. So we could create a class that will embody the root, and then it will, or rather the node, it will embody the node, and then also the level, so that we can keep track of the level. Or in my own case, I think I will just go with a tuple, where it will just have a level and a node. Basically, that's what I will actually be queuing for each of them. So I think this is basically what we will go about to do, and I think we should be able to come up with something good. So let's get to it. So here we have our LeetCode question, and we're going to solve it here. So what we'll just need to do is, for this we need our queue, because we'll be using breadth first search. So let's just have a queue, and it's going to be a queue of a tuple of the level and the node actually that we want, which is 3 node, for example, here. Okay, so we have created our queue, and let me just create results. Let me just know that that's out of the way, and then I know I have to return my result at the end of the day. So you remember that we queue the root, so we have to queue this, and queue. So but since it's a tuple, the level, I know for this first one, the root, the level is always going to be 0. Okay, and so what we will now be doing is, while our queue, while there is an item there, so y is greater than 0, we want to keep going through it and checking it. So let me call this node, and then we will just dequeue it. So whatever is the next item to be dequeued will just be dequeued. And after we dequeue it, so what we could just do is, if I'm dequeuing it, then I just check, okay, if I just check the level. So I need a way to track the level. Okay, so let's have a variable. So let's have its current level, and the current level at the beginning is 0. So let's have something like current sum, right? And current sum, and then let's have current count, so that we can calculate the average. That's what we use to calculate the average, the sum and then the count. So okay, so what I want to be doing, because I know that each level will follow each other, so at the point when I see a different level, I know that I am to, so yes, so what we could do is, if the level, okay, so you know, I know this is a tuple, so I should return the level and then the node. Okay, so this is how it should be since it's a tuple. So if the level of this node is not equals to, or if the level is the same, let's do that. I think that's easier for me to also understand that. So if we're in the same level with, oh sorry, this will be current level. If we're in the same level that we are currently working on, so it means we could just do our current sum, and that's just going to be node dot val. Now, oh, so I didn't notice this. This is a binary tree, I think. Yes, it was mentioned. I wasn't careful about it. So it's a binary tree, meaning it only has 2 children at most. It cannot have more than 2 children. So that is what a binary tree is. It always have 2 children. So for example, you see this tree has 9 and 20, 20 has 15 and 7. So here we just have, so we sum for our current sum, and then we also need to keep track of the count, so that would be plus plus. So basically what we're doing is we're getting the sum and the count, but when it is no more equal, that means maybe we're in level 1 and we are going to level 2, it means that my level, the level of that node, will not more be corresponding with the current level. So I know that I have to calculate my average, sorry. So average is going to be, since it's a double, so I need to just, let me cast them to double. So the current sum divided by the current count, so that will give me the average, and then I could just add that to my list. So result dot add, and since I know it's doing it level by level, so I know it will finish level 0 before level 1 before level 2, so I can just add it to the list, knowing that they will always follow sequentially. So and then my current sum, I will now reset it back to the current value. So node.val, and then my count also, I have to reset my count, is 0. So okay, no, it's going to be 1 because we are starting a new one at this level, so it's going to be 1. So what we are doing here, we are saying that okay, we are calculating the average, and then for the new level we are beginning to go through it. So what we want to do next is that, okay, after doing this, we want to enqueue. So whether it is having a level of this or not having, we want to enqueue the next nodes. So we just will do node, sorry, we want to enqueue, so that is queue.enqueue. We want to add the node, we want to add what is on the left, and want to queue up what is on the right. So basically what we're doing is we're putting whatever is in the left and in the right of the particular node we are on. So it means we need to check for null. Okay, so if it is not null, that is when I want to do this. So if it is null, what do I want to do? So if node is not equals to null, or let me just do if it's null, so I just continue. Okay, no, I think I just do if it's not equals to null, and then I just encapsulate it here. So basically I'm just saying if it's not null, then that's when I want to do anything. If it's null, then just dequeue it and go to the next again and continue with your operation. So we're saying if it's not equals to null, then we check the current level. If it's still the same level, then we want to continue summing up and get get the total count, and then if it's not the same level, it means that we're just moving from one level, maybe between levels 1 and 2 or level 0 and 1, and then we need to calculate the previous levels, and then we add it to our list, and then we now start the new one there. And then either case, we want to enqueue the children of that particular node. So I think this should be fine. Let's run this and see. Okay, so we have an issue. It says a queued cannot be used like a method. Why will it say I'm using as a method? So it says we are queuing up queue, and we put in the int, we pass in the tree node. Oh, sorry. We did not instantiate it, so new is that. Let me see. Let me run it again and let's see. Hopefully all is good. Okay, still have an issue. Cannot convert tree node to, that's line 34. Oh, sorry, I was not. So you know, we are supposed, the queue is expecting a level, an integer, and a node. So but I'm only passing in the node, so I need to pass in the level. So I know that the level of that node will be one level. So if I was in level 0, I know that the children will be level 1. So all I just need to do is the level, the current level plus 1 will be the level of those children. So I could just, so this will be current level plus 1, and then we close that. So let's run this again and see. I think we are clear with any issue, but let's see. Okay, but it doesn't pass. So we had 9, 20, 15 rather than what we were expecting. So let's just look at it and see why and where we could be missing it. So it got for the first, but for the next few nodes, it wasn't okay. So we are summing up this. If the levels are the same, we are summing up, but if the levels are not the same, okay, so we are resetting it here, we are resetting it to the value, and we are setting this to 1. Yes, it looks fine here with me. Did I instantiate something wrongly? So let's look at it again. So we're adding to the result. So because I can see this is supposed to be 29, I'm not sure why it summed up, and then we have only 15. Maybe it didn't sum up the 7. Okay. So here we are getting the average, the sum. Did I miss the sum at any point? So at the beginning, we're in level 0, so level 0 and 0, that's fine. Then when it goes to 1, oh, where am I moving my level? Oh, okay. Oh, I need to change the level too. So at this point, it means that it's in a new level. Yes. So I was supposed to set the level, you know, because there is no way for it to know the level where it is. So I'm supposed to say, okay, when you are at this point, it means your level has moved to the next level. So, you know, because what is here now, the level previously was maybe 0, but it's still coming back to check for level 0. So that was likely the issue. So let's see. Okay, we still are feeling it's not going through the, okay, so you know, this will only continue till the end. Now at the end, we still need to, because for the very last one, it will not exist there yet. We need to do the submission for that. So let's just save AVGs, and then we just do the same calculation we just did over there. I could have just copied that, but let me just type that, and then divide it by double the current count, and then we just add that to our result, and let's see what we have here. So basically, it's because this we are queuing up, and then at the end of the queue, actually the last level will be ignored here, because at the end of it, it only just took the sum of it. So what we just do is, after the loop, we know that there is one more level that needs to be calculated for, and then we just, based on the sum and the count, and everything is very fine here. So let's try and submit and see if we are clear with that. I believe we should be able to get this done Okay. Oh, so these are the items. So it means that we need a double here. So it means my sum, I'll make it a double uh, because I want it to be able to take, because an integer, this is the maximum of an integer. So even when I sum this and this, because these are the max of integer, it will have overflow, and then the data will no more be correct anymore because the integer can only take as large as this value. So initially, by default, a 0 means an integer. So basically, this should fix that. Let's see. Hopefully no more issues, and yes, we are clear with that. So basically we see that when we have a question like this that we are having to do with hierarchy or the levels of the tree, we can just use the breadth first search by using a queue to enqueue and dequeue respectively. And you saw the way we just use tuple to just keep track of the level, and for each level we are able to perform the operation we wanted to perform. And don't forget, we also enqueued the left and the right because this is a binary tree. So basically, this is how to do the average of levels in binary tree. I hope this was insightful. I hope this was helpful. If you have any questions, please drop them in the comment sections and I will do respond. Thank you, and I'll see us in the next video.